Hi class, let's take a look at example 5. Now example 5, it's unfortunately a problem that has to do with homicides, and they're basically, or we're actually going to see this actual number with the actual units as technically the number of successes for this event. So the formulas that we're going to be using, they're basically on the handout. In this case, we know that the problem is a Poisson because your interval happens to be a year. So remember that a Poisson, if the event is defined as a Poisson, there is some sort of an interval or area that they mention in the problem. So in this case, the mean, it's going to represent the number of successes divided by the interval. And then here we have the formulas for the mean and the standard deviation. Your usual interval, notice that we're still talking about within 2 standard deviations away from the mean. That's because some Poisson problems for large values of E are going to be bell-shaped, or they're going to have portions where it kind of looks like a bell-shaped distribution. Okay, so let's take a look at some of these values. Now, in this case, the value of the mean, we're going to use it as 116 divided by 365. So 365, I'm getting that this is approximately 0.31 78. And I'm just rounding to 4 decimal places. Let me double check. 116 divided by 365, 0.3178. Now, if they mention for us to get the expected value, we're going to be using the rounded value, but we're going to round it to the nearest integer. So the actual value of the mean was approximately 0.3178, which if you round to the nearest integer, since technically it's 0.31, this is going to be 0. And when we're talking about the expected value, they're going to want units. So in this case, this is a positive expected value. You expect 0 deaths in this particular city. So technically, this will be Richmond, Virginia. Okay, and the formulas for the actual variance, you're just using the values of the mu. Some of the software problems may want you to use the exact value, in this case 116 divided by the values of 365, which is approximately the 0.3178. On my end, decimals are fine. I do want to see where you're getting that exact value. And for the standard deviation, this one's going to be, well, technically the square root of 116 divided by 365, which is approximately, and let me punch it in into the calculator. I'm getting that this will be 0.5637, rounding to 4 decimal places. Now, when they're talking about the usual number, in this case, the last portion, this is going to be referring to the usual interval. In other words, they're asking what would be the typical amount of deaths in this city. So remember that some of these Poissons could be looking bell-shaped. So you're going to see the same values for the usual interval. So let me punch these in. So I'm just going to use the decimal values. So in this case, this will be, or I'm just going to call it approximately, since technically there was a little bit of rounding. So the mean was 0.3178 minus 2 times 0.5637. And then the lower bound would be 0.3178 Whoops, I have it backwards. This is the plus and this is the minus. Minus 2 times 0.5637, and I'm getting the following. So 0.3178 minus 2 times the 0.5637. Okay, so in this case I'm getting, and let me double check. Okay, so the lower bound I'm getting negative 0.8096, upper bound 1.4452, which we're gonna have to round to technically, well, they're only looking at integers in terms of homicides. So this is gonna be 0 to the values of 1. So in this case, the usual number or the usual interval is equal to anywhere between 0 to 1 homicides. And let me just double check the calculation here. Okay, we're good on this one. I don't see any errors. So let's move on to the second portion. And the second portion of the problem, in this case part B, it's going to want us to do evaluations. The first one has to do with find the probability that we see 0 homicides. So we're going to be carrying out 2 types of evaluations. If they mention a specific value, it'll be the Poisson PDF. If they mention a less than or equal, or if they were to mention a greater, we would have to adjust it to the CDF. So for the very first one, I put the code there, but I'll run it in a minute. So they just want us to evaluate, and don't forget to declare, in this case, homicides in the city. They want us to find the probability that there is a total of 0 homicides. So after you declare X is equal to homicides, we're going to be evaluating the probability of X is equal to 0. Now in the calculator, we're going to have to do since it wants a specific value, we're going to have to activate the Poisson PDF. And then the mean was 116 divided by 365, and then they want 0 successes. So I'm looking at 0.7277. Once again, the code on the PDF or the CDF, you're putting mu and then the successes. So in this case, this value here represents your mu or lambda, and this would be your X value. So for 0 homicides, we're looking at 0.7277. And let me just double check. 7277. Let's move on to C. C wants 1 homicide. So in this case, you could just retrieve the previous answer and then change the 0 to 1. 1 homicide ends up being the probability of 2313. So I put the code here. So 1 homicide, and we don't have to declare it again since we technically already did that. This would be the probability of X is equal to 1. So it's going to be approximately 0.23, technically rounding to a 3. So 1/3. So 0.2313. Next evaluation is asking for 4 homicides. I already put the code here. In this case, for 4. So this is going to be the probability of X is equal to 4. In this case, we're looking at 3.09. times 10 to the negative 4. On my end, this is perfectly fine. Some of the problems are going to want you to rewrite it as a decimal. So in this case, we're talking about 0.000 and then 309. So you're counting the points, the spots. So in this case, 1, 2, 3, and 4. That would be the negative 4. Both of those answers are perfectly fine. Sometimes the calculator will give you the answer automatically as a decimal. Okay, let's take a look at the E portion. And less than 5, so this one tends to be a little bit tricky because of the random variable being discrete. So when we're talking about the Poisson distribution, you're looking at your x's to be integers. So here, if it says less than, you're not going to include the upper bound. So for this particular problem, they're asking for less than 5. So in this case, this is going to be the probability of x less than 5, which really means the probability of x less than or equal to the values of 4. Or the probability of x is equal to 0 plus the probability of x is equal to 1 plus the probability of x is equal to 2 plus the probability of x is equal to 3 and then plus the probability of x is equal to 4. Or another way of viewing it is this will be your Poisson CDF. I already put the code there, and just keep in mind that less than 5 means less than or equal to 4. So for this one, you would be evaluating the Poisson PDF with 116 divided by 365. Whoops, there's a comma there, and then 4, which will give us the whoops, I ran the incorrect one. It's supposed to be the PDF. So, CDF. So 116 divided by 365, comma, the values of 4. There we go. Okay, that looks more accurate since it's adding all of them. So I'll just write it as 0.99, 99, or approximately 1. In this case, I'm just going to rewrite it as approximately 0.99. There is 1, 2, 3, 4, and then technically an 8, which is technically almost 1. I'm just going to keep a couple more decimals. So I see 4 9s and then an 8, which is literally almost 1. Once again, in this scenario, we're evaluating a CDF because the statement translates to a less than or equal to an integer. Now, in the same format, if they want a greater than, so in this case, the probability of x is greater than 5, well, that would be equivalent to this calculation, but you're not given an upper bound. And technically, there could be an extremely large value of homicides in the city. So that 116, it's not technically all the ones that there could be. That's just a number. And in this case, we're going to use the complement. And the complement is 1 minus the probability of x is less than or equal to 4. For the less than or equal to 4, we would use the CDF. And this is going to give us 1 minus the calculation. I'm just going to carry out to 5 places. So 1 minus 0.99. So the complement would give us the 0.99998. 1 minus that as a scientific notation is 2 times 10 to the negative 5, or 0.00002.